moment
I'm
now?
studying the Mempool, mainly for Ethereum and L1 because it's the most secure EVM we have right now. Let's see what happens with the Bitcoin L2s. Who knows? Okay, excellent. So hello Mempool, push boundaries, invoke Rolamate. We are going to explore the Mempool territory. So what is the Mempool? Here, someone knows what the Mempool is? Can you put your hand up? 1, 2, 3, 4, 5, 6, 7. Okay, it's a lot. Excellent. It's the first time there is more than the 50% knowing the mempool. But for the others that doesn't know, is the ethereal space where the transactions are waiting to be executed into blocks. So to interact in the Ethereum Mainnet, what we do usually is to send a transactions to RPC. This is validated by the own node that we are interacting to. It's received by the queue of this node, and then is integrated into his own mempool. There is no one mempool. The mempool is something that is shared between all the nodes, and sometimes one transaction never reaches many nodes that are in other parts of the planet. So there is not one mempool. The content between all the mempools that exist is about 20%. At the highest rate is 80%, but there is always at less than 20% that as a standard rate is unique for each node. So what happens in the mempool? The user uses a wallet and then interacts with the mempool if we forget all these inner transactions. So each node will receive the transaction from the user into a local queue. This will be validated by the own node. This says, okay, this user, this account has balance, the nonce is valid, the signature is correct. I will include into my mempool and I will spread it, broadcasting. So for what is the mempool? Today, the mempool behaves like a waiting line. That the first ones are the ones that are paying more. Okay, so if you want to pay more, you get first in the blocks. Everybody knows more or less how this works, but why this should be like that? I don't agree very much. I don't know if somebody from here went to Cuba. In Cuba, there is an ice cream store that is called Copelia, where in one line, you pay cheap, and in the other line, you pay like 10 times more. Of course, tourists go to the line that pays 10 times more, that is cheap anyway, and you get your ice cream. But why? Why this should be like that? Well, the same that is like strange for us because it's a clear example is happening right now on the mempool and Ethereum. So let's have some fun. Have you ever thought about the hidden features of the mempool? I mean, the mempool is reliable. It's a source of truth, but not in blocks, because we say that the blocks is a unique source of truth of the blockchain, but the mempool is still being a source of truth. It's broadcasted, it's cheap, to don't say almost free, it's reasonable fast, 0.1 seconds to have a transaction that is looking very good within the 80% of the nodes, that is fast for the size of Ethereum. It's a clear path, sender received. No hijacking, because all the protocols that we know until today that are easy to use are subject to being hijacked. No spoofing at protocol level. So isn't this beautiful? So what we did, I, myself, and my company, we invented something that is called Rolamate. We solved the expensive gas and slow speed problem on Ethereum L1 mainnet. So we took this feature that we are using the mempool for this to invent an ETH payment meta protocol for Ethereum mainnet to send crypto payment with a less 95% discounts on gas fees. And of course, this also works for ERC20s, leveraging these two mempool features, very low gas fees and reducing nonce. So at the end of the day, the user just connects to Ethereum mainnet, deposits, pays, and withdraws normally using any wallet. So relying on the mempool capabilities, the relayers that are the nodes capture all these transactions, are part of our meta protocol as well, because we put some code on them, and we validate the transactions, and we send them to a different chain, a side chain that now can be an Avalanche chain, can be an Orbit, or any other chain that also could have no gas. So in a decentralized and permissionless way, I'm going to show how this works a little.
Welcome to the first demo video of Rolla Mathi. On the right side we can find a brand new wallet of a store called Mathi Store. As you can see, this wallet has 0 ETH. On the left side we have a wallet that already has 0.0065 ETH, that here is rounded up, but in MetaMask we can see the exact balance. For this demo we will use the Rolla Mathi payment protocol to send ETH from the left wallet to the right wallet without paying gas for the ETH transfers. So, the first thing to do is a deposit of ETH into the Rolla Mathi meta protocol. This transaction should be included into blocks, so we are going to pay the gas for it, that luckily now is cheap at 26 cents. We need to wait for this transaction to be confirmed, so our deposited ETH will become available to use in the Rolla Mathi payment protocol. Once this happens, we will be able to send payments using Ethereum Mainnet with at least a 95% savings on gas fees, but, for this example, all the ETH transfers will be completely free, since we will not be doing a high demand. Feel free to ask how this works in the comments. Now, we are in the pay section, so we will start to send ETH from the left wallet to the right wallet. This DApp is just a transaction constructor that let the user configure an ETH amount in the destination wallet, then the transaction is constructed with low gas, just enough to be valid, then broadcasted to the Mempool, and finally captured by our Rolla Mathi anonymous node that will process it without need of a confirmation. Let's repeat the process as many times as needed to transfer all the ETH from the left wallet to the right wallet. As you can see, the left wallet ETH balance in Ethereum Mainnet remains always the same and all the already processed transactions are in a pending state. This is because Rolla Mathi meta protocol doesn't need the transactions to be confirmed, we need them just to be broadcasted. A broadcasted transaction information is as valid as the information of a confirmed one, but not permanently since is not included into any blocks yet. For the last ETH transfer of this demo, we are going to show you how to construct your own transaction manually. You will see how it will work as well. This permissionless, trustless, and decentralization level will help the developers to integrate Rolla Mathi very easily into their products. First, we configure a transaction to the Rolla Mathi smart contract for 0 ETH value, but in the hex data, which contains the ETH transfer information in the Rolla Mathi meta protocol format, we configured a 0.001 ETH transfer. Then we configure the gas price to be so low to not be processed, but valid enough to be accepted by the RPC and broadcasted. As you can see, the transaction goes through and is confirmed for both wallets. Now it's time for the withdrawal, so the Mathi store starts it. As this transaction needs to be confirmed, it will pay a gas fee, which in this demo version we are handling for security reasons. Finally, the Mathi store receives the withdrawed balance, and thanks to Rolla Mathi payment protocol, no one had to pay gas fees for any of the wallet-to-wallet ETH transfers. Welcome to the...
Well, this is a demo that is working. This was made in October of past year. Right now, we mounted a wall meta protocol, a virtual EVM, a EVM, on a sidechain. So now we are going to use smart contracts, account abstraction, and many other use cases of EVM, and people can build their own meta protocols on the same technology that we are using Rolla Mathi. And now I want to show another use case for the Mempool.
ACID chain protocols start deploying ACID chains. ACID is pushing Ethereum's scalability to the maximum while providing faster transaction processing, ideally for gaming, DAOs, token swaps, interoperability, DeFi, data sharing, and decentralized exchanges.
Yes.
So, which is the problem that we are facing? Ethereum scalability issue limits transaction speed and volume, leading to network congestion.
So basically
and
here we want to give more scalability to Ethereum without changing the infrastructure. So we think anyone can leverage their own also virtual machines on the Mempool of Ethereum 1. What we think is why every protocol, every blockchain has to have their own Mempool. It's like making a highway or roads for your city every time you make one and don't use the main road that is there. So now what happens is we have slow speed, lots of congestion, hyper gas, and we have layer 1, the users, and the mainnet mempool. What we proposed here and made a proof of concept was what happens if we have a layer 1.5 that is sharing the mainnet mempool with Ethereum L1, just having different gas specifications, and the trade-off will happen anyway. So what happens here is you have a standard node, they share it in Mempool, a ACID virtual machine, that could be any. You will have, in this case, we use Cartesian hard hat. We have the meta transactions in the layer 1.5, and then you have checkpoints that is the same that the rollups does, but this will happen organically. So what you will have, the ACID virtual machine, you can, well, here is just a table of contents, and then I want to show you the last example of what we just done, that is streaming video and radio using Ethereum L1 node without paying gas. So we were literally...
Welcome to Patio Station. Stream video and radio using Ethereum L1 nodes as infrastructure without paying gas. How this works? You can cast. You just need to connect your wallet using your private key, input audio or video, then the transactions will start going out through the RPC node, and then this goes to the mempool and be spread all across the blockchain infrastructure using the nodes. So to view is very easy. You just need to put the station address, tune in, and then you start consuming it directly from the mempool API or the node. Enjoy and donate. So how is the tech stack? We use incremental gas plus decremental transaction weight. This lets us do 1.2 megabytes per minute. This means high processing probability zone avoided, and we are making big data weight transactions with low gas fees, and then we decrease the data weight and we increase the gas fees, so we avoid this to happen. So congrats, we're in L1. No. We are delving into a real solution for a global problem: communication censorship by powerful groups. In an out-of-band scenario, this solution offers a clean and readily available method to guarantee and secure authenticated communication. So let's go with the demo, guys. Here is the demo where first a caster will put his private key here for the proof of concept, and then he will be uploading his input file that will be a radio or audio, and then he will be start casting. The transaction will go through the mempool and he can receive donations. And then we can see a user that is consuming this information, directly putting his address in the nav bar of PATIO radio. So enjoy it and thank you.
So, well, I will change to the switch to the presentation. So the retribution compromise is, we know that this feature was not designed as it is. So it should be considered as a fair use commitment, at least as intentions for any developer until this is incorporated. I'm talking with the Ethereum Foundation about this. They are worried a little, of course, because it can finalize in some spamming, in some blockout of the mempool of L1. So we need to find some way to retribute paying gas every end transactions, because with all these protocols I was showing you, you are not paying any gas on L1, and you are consuming in high demand the nodes if you want. So also don't use future nodes, because there is few vulnerabilities in Ethereum L1. I shouldn't disclose, but I will. So it's like you can use any nonce. In fact, you don't need to use consecutive nonce. And there is some attacks that you can accumulate nonces in the future. Then you just send one to reactivate all of them. And maybe you can send 100 transactions just in the same block. I won't set valid transactions to transmit. And well, this is a little more of information. And well, have a great meta protocol development journey. This is this QR. I don't remember where it takes you, but will be to some place that is good. I'm ariutokintumi in Twitter. And well, we are developing meta protocols on the L1 mempool, on any mempool. So do you have any question?
Are there any questions in the audience? Oh, I think I saw two.
I just wanted to ask if that's also going to be applicable in some moment if layer 2s also get a little bit congested and a little more expensive. Would that be also applicable on layer 2s?
Sorry, the last part.
Your protocol, would it be usable on layer 2s?
And L2s, yes, of course. You can use it on L2s. And in L2s, it's extremely more, let's say, more free. You can say more free, even more free, because L2s usually has extremely high gases prices. I mean, the gas at the end of the day is low, but the gas price, the gas limit, and the priority fee are extremely higher than on L1 in quantitative matters. So yes, you can use it, and this will be even better for you. But we are doing all this on L1 because we feel it's the biggest, strongest, and more prepared mempool. Bitcoin also, but we want to do all these things in Ethereum now.
We have one more question.
Hi. I wanted to understand a bit more, like, if everyone starts doing this and, you know, sending a lot of transactions to Mempool, etc., that's going to lead to, like, some sort of spam. But are the transactions going to go through, or is it going to get, like, congested as a normal transaction? Like, if it's not just yourself, but, like, you know, 10,000 more users doing all of this and broadcasting and streaming and doing all of this stuff?
Yes, well, that's the thing that is worrying Ethereum at the moment. It's a fair question. Your transactions should pass after you reuse the nodes. I didn't specify there. That's why I asked if many people knows or not how the mempool works. But you can always reuse a node. So people use this function only to cancel transactions sometimes, and they pay a little more gas in gas price. Sometimes it's less gas in the real price, because there is a kind of feature with a vulnerability. I don't know if I'm live on internet, but well, it's a vulnerability that in the protocol they planned to tell you, okay, if you increase the gas price and the priority fee by 10%, you can replace your transaction. They found this, I don't know who, I'm sure it was someone in a chair that said, let's do this, that this happens with these kind of decisions. To make, okay, you will reuse these nodes, you already consume some data and processing from the node, so the trade-off will be like you pay 10% more, and we hear it to you again, but if you decrease the gas limit, your transaction will pay less. So you start doing high demand transactions with a lot of data, maybe 40 kilobytes that you can send on a transaction is almost the limit. And then you send another one with 10% more gas price, priority fee, but 10% less data. This will pass through, and you start doing this until you have a transaction with gas limit in 21,000, that is the smallest. You will have about 8 of gas price and 2 on priority fee, and this transaction is never going to be processed because the gas prices are always like 19, 20 to 40, 100. But if this gets processed someday, you will pay about 60 cents. But then if you are doing this and this and this and this, you will have like 100 pending transactions. But the first one that is taken to calculate if the transaction could go or not is the first one. So the next ones are part of the first one in the summatory of how much money do you have in your account to take it or not. But in the first one, you can replace it to a transfer. So you get out all the funds that were collateralizing all the 100 transactions, and this one go through, and the next one will be automatically dropped, canceled. A transaction is never dropped. Be careful. If you get money in your wallet again, all of them will be realized maybe and processed. So you have to be careful about this.
Thank you so much, Germán.
Thank you.
Thank you also to the audience.